Hello, my name is Miss Clett. I hope you guys are having a great day so far. Today we're going to be talking a little bit about ecological population. So, if at any time you need to, you may pause and write down the notes. So, let's begin. So, what is population? How does population change? What are some factors that can change population? What is carrying capacity? These are some of the questions that will be answered in the notes. So, a population is a group of interbreeding individuals. So, these are multiple different individuals that are singular, but all together make up, in one species, make up a population. So, all the human population, as you guys can see, my puppers in the background, all the canines all the canines make one species. Most live together in a group where resources are available, protection from predators, and predators have a better chance on getting meals. So we got two different types of population growth curves. We got the J curve, which is going to be this one right here, showing that this is an exponential growth, meaning that there's no limit. There's going to be continuous growth. It will never stop. Population growth rate increases as the population gets larger. And after obtaining peak value, eventually we'll hit a crash eventually. But it depends on an infinite amount of resources. Right now, humans are considered to have an exponential growth because we have not, as a human population on the planet, have not stopped growing. Next one is an S-shaped curve, or the logistics growth, meaning that it does eventually slow down. So we're starting to see like, oh yeah, we did increase a lot, and then there's some factors that have occurred to stop the population from growing any higher. Growth rate eventually slows down, and making an S-shaped curve. Carrying capacity is also known as K, represents where the population level's off, and it depends on the environment and the resources. So carrying capacity is the maximum population of a species that a habitat can sustain indefinitely. And it does really truly depend on the resources. So 4 variables that govern changes in population size is birth, death, immigration, or emigration. So immigration is coming into the area. Emigration is exiting the area. The formula for either humans and or animals or plants is population is birth plus emigration minus death plus emigration, depending on what's going on. Some limiting factors, chemical, physical factors that could determine the number of organisms in a population, helps regulate the population growth, especially for humans as well. Factors that can limit populations: weather and climate, food, nutrients, pollutants, seasonal cycles, disease, competition, predation, and catastrophic factors. There's multiple different things, but just to get the logistics of it. Population density is just telling us like how many individuals of a population are within an area. So like in my area that I live in, I live close to the city. Like I'm on the outskirts of the city. Where I live, not so many people. If I was to go about 2-3 miles in one direction, I'd be hitting a bigger population density. Density independent factors are such as weather and climate, food, nutrients, limitations, pollutions or pollutants exerts their influence on any population size. Deals with both physical and chemical events. Density dependent are like diseases, competition, predation that could influence the population. Usually from the biological aspect. So independent deals with physical and chemical events, whereas density dependent variable deals with biological events that have happened to occur to humans. Survivorships. We got 3 different kinds. Type 1, we have type 1 curve, have very few births, and have longer life expectancies. The young tend to get more parental care, more successful for long life, high survivorship rates. usually large mammals. Humans, we are considered mammals. Dolphins, they're mammals. Elephants, mammals. We tend to, all the ones that have a type 1 curve, tend to have very few kids or not as many kids. And when I mean few kids, I mean less than 10 like less than 10 in a human's lifetime, give or take. Um, we tend to keep our kids a lot longer. They survive longer, and then eventually they die off after a very long successful life. Type 2 curves have more birds, but some parental care. They have more birds, so like every single year they have about 4 or 5 babies per year. Or eggs, or a couple dozen eggs. More birds, some parental care. They get some parental, but they don't last as long. Like they don't have the parental care like mammals do for a couple years. They only do it for like a couple weeks to a couple months, and then they say bye-bye and fly off and go off and try. Which then does a steady decrease throughout their life because they don't have the longer parental care to help them over a long period of time. Usually your lizards, your birds, and your rodents. And our last type of survivorship curve is type 3. We have lots of birds, and when I mean lots, I mean like hundreds per batch. And very short life expectancy because there's been no parental care. So like your tree seeds, they tend to produce thousands of seeds, and maybe throughout the thousands of seeds, only 10 survive. There is no parental care. Very short life expectancies, low survivorship rates, and this is usually like your mammals, fishes, invertebrates. They have thousands of eggs, and maybe only 10 of them survive. It's just on how these species have learned to grow. And that is it. I hope you guys have a great day. We will talk more here soon. And I hope you guys have a great day again. If you have any questions, come see me. Bye.